Hello guys and welcome back. So now I wanted to show you guys one way of creating something like this. It's not exactly 100% art controllable, but I want to show a unique usage of the soft deform in Houdini. And I'm gonna create a geometry. I'm gonna have this on my side screen to follow some of the proportions, but basically the idea is, let's say we're gonna start from here all the way up and try to create something that resembles to this. Okay, and I'm gonna start with a, let's say, with a line for this arc here. So I'm gonna add tons of points to this, and then I'm going to select a point at the center. So 20, let's do 21. I'm gonna hit tab, select the point, hit tab in the viewport, type in soft transform and hit enter. Now I'm gonna move this to the side. You can see we're getting this interesting curvature. Now with the soft transform, there is few controls that we can use. This is this controls the fall off, but what I'm really interested in is this guy. So by tweaking this, we have control over an interesting control over the shape of this. So I'm gonna do something like that. Let's move it back. Okay, and let's transform this guy, maybe scale it down, and let's move it up here. And I'm gonna copy the soft transform. And because it's the same, this point number will also work. So let me template this, and let's reduce the radius. Okay, and I want to create something like this. Okay, now you can see this we're offsetting we're selecting the points at the center. I don't want that, so I'm gonna click here. And let's change the point to be the top one. And now let's increase the radius. Cool, we're grabbing everything. Let's move it back. And let's play with this value. Cool, so I'm not gonna follow 100% this silhouette, but I'm gonna try to create something like this. So the next one is a circle. I'm gonna copy the same thing. So let me transform this, scale it down, and let's move it up, and let's template this. And when we do this, we have to be aware that we're making a copy of this. So whenever we change the base, this will change. So if we build something based off of this, we're gonna have to keep a track of that. Okay, let's add another line and just do something of our own. We don't have to follow this exactly. So I'm gonna move this here, and let's copy this soft transform. Actually, let's create a new one because it's the pivot gets set based on the geometry. And let's merge these two so we can just view one node and see the result. Okay, let's do this. Okay, and let's also connect this so we see everything at the same time. Cool, let's create a soft transform. Actually, you know what? I'm gonna disconnect this because I want to use the viewport, and if we have all of them together, it will create the soft transform here. I don't want that. So I'm gonna select a point at the center. Soft transform. Let's move this in. Let's reduce the region, and let's play with these guys. And maybe we're gonna change it to 19. So grab the 20. We grab the point at the top instead. And what I wanted to show you guys from this video is this node can be very, very powerful if you know when to use it. Okay, let's keep that. Maybe move this here. Let's do one more copy of this. I connected this section so I can see all of it. And I want to do, I want the shape to go back this way, but I also want some a 3D curvature in it. So I'm going to rotate the curve this way, 90 degrees, and I'm going to delete this soft transform. I don't need it. I'm going to create a new one from scratch. So I'm going to select this point, hit soft transform. I'm going to move this down. Okay, and we can also increase the point if we need more precision in the geometry. So this, when we loft it, is going to create a interesting geometry. Cool. So to speed this process, I'm going to do a few transforms to save time. So I'm gonna copy this, and right now you can see the transform is set here. I want it to be local to the object, so I'm gonna type in $CX, $CY, $CZ, and this will return the local pivot of this geometry, so I can move it based on its local axis. Okay. Are we ready? We already moved it. So let me delete this. Let me change this to 90. I messed up something. Sorry about that. Let me undo a few more times. Okay. Let's copy this. Let's add this here. And I'm going to create a transform. And I want it to be local to this guy. So $CX, $CY, $CZ. And this is a Houdini expression. Copy this minus 90. Let's scale it up a bit. Move it here, and I think that's it for this. I just wanted some silhouette, and I have that now. So let's make something interesting out of this. Let's create a right now all these points, the connection is separate, and I want to join them. And to do that, I'm going to use a node called join. This is very underutilized node, I think. It finds the nearest openings in the geometry and tries to connect that, and it's actually very, very powerful. So now we have filled in all these connections. That's why I was not worried at the beginning. And then what I'm going to do is I'm going to let's see what's the best way. Yeah, I'm not going to. So let me just extrude this, and with the extrude, I'm going to turn on extrude, transform extruded front. I'm going to change it to global. Let's hit enter in the viewport. We can move it back, and you can see we're creating this geometry. No, the extrude is not going to work. Sorry about that. So let's take these 2 points and let's transform them. And I'm going to scale them. I'm going to move them down a bit so they're aligned. Same here. And let's use a join again. And I want to join all these guys. So with the wrap to last, it finds the opening and connects it automatically. With the tolerance, you can decide how much it affects the previous geometry, so we can control that, whether it takes into account these points or not. And that's what the tolerance does. We can shift the connection point to go to along the U direction, and the higher, the closer to one of the sides. So I'm going to leave that to be 1. I'm going to set this to 0, and now we have filled the geometry. If we go back, this is the original geometry. I changed that so it's flat, and then with the join we can fill that. Now I'm going to move this to the center. I'll explain why in a second. And I'm going to do that using a transform node. So I'm going to hit move to centroid, and I don't want any change on the Z axis, on the Y axis. And let's move it down a bit. I hit escape because it was showing the tool for this node, and I'm going to select this node and hit enter in the viewport, and that gives me the handle for the current node. And I want this point, I want to shift it along the x-axis. I'll explain why in a second. And then I'm going to use a revolve node, and what this does, it's going to do this, basically revolve the geometry, and then fill it with actual geometry. So you can see we have this interesting detail here. We have all the details that we've created, and we can go under details and increase the division. The higher, the more resolution we get in the geometry. And we can change the center of the revolve, and we can also move this guy, our original geometry, if we wanted to. Sorry, not along this axis. Yeah. Okay, so let's say we wanted to create a square where we have this detail in the corner. So let me make this bigger. I want to make it thicker, so I'm gonna select that edge and move it. Now let's do a revolve, and I feel like the revolve is not, I want these edges to be aligned, so let's make sure the center is at 0, 0. Cool. And this guy should not have any transformation along. Yeah, it's okay to have transforms along these Z and the X and Y, but I want it to be aligned. Actually, no. I want to align these guys, but it's fine. So what I want to do next is I want to create 4 corners that are rounded, and then have this geometry extend to create a square. So what I'm going to do is I'm going to use a clip node. And with this clip, you can tell it, you can give it an axis and an origin. You can see as I move it up, it clips the geometry. This is not a boolean, this is actually removing the geometry. So I'm going to align it to the Z axis, like that. And I'm going to do another one and align it to the x-axis. So I want just a corner from this. And now that I have these 2 silhouettes, I'm going to extrude them. Let's extrude this. Transform. I don't want to use this because it's going to use the normals. I don't want to, based off of that, I'm going to use the transform extended and use it, set it to global. So I'm going to extrude that, do the same thing, and yeah, let's do the same thing here. Extrude, on that edge. Global, let's move this. Cool. And I'm going to simply mirror this now. Something like that. And then I'm going to mirror the whole thing one more time along the z-axis. And now we have this interesting detail that we can use in between pillars or anything like that in our environment. Let's add a fuse node to fuse in some of the points. There are probably still some openings here, but I'm not going to worry about that at this point. I just want to show the soft transform usage and how it can be used to create some interesting details. So we have that. We can go back now to this guy, okay, and let's add a transform. I want to make it more complicated. So let's copy this, move it, and let's scale it up. Now, because of all the specific operations that we did that are based off the point count, it's going to be we're going to have to adjust all of those because there's nothing procedural about those nodes. So for example, this node, this should work though. Okay, so let's do a fuse first to connect these guys, and I don't need a joint anymore. So I think, oh, you know what? Let's do a joint before we transform it because it was working fine at that level. Okay, let's add a fuse so everything is connected together, I think. And then the transform now is not those 2 points anymore. So I'm going to select this. And I'm going to select this point and hit enter. And then what is this? Yeah. So here we need to extend this a bit more, and we're going to flatten it. So let's find the axis. It's the x-axis. So I'm going to set this to 0, and both points are aligned. Let's join that. Transform, I don't need this edit. Let's revolve. Still works. Okay, let's see where this gone wrong. So the clip is working. Cool. And the poly extrude is not, which makes sense. You can see also we're getting some interior geometry, but I'm not gonna fix that for now. It's fine. I just want to show that we need to update all these. Sorry, this is the part. Okay, so I'm gonna hit the edit for the extrude, change the section that is needed to be selected. This is the other section. Hit enter. And then let's mirror these guys, and everything works. So if we find a way to make this edge selection procedural, then we're in a good shape. We can easily tell it to use that group if we procedurally select these edges. So let's do this. I'm going to create a group node. Okay, I'm going to tick on keep in bounding region, and I'm going to select everything here. Let's put this in. I'm going to change it to edges. I want to grab everything in this small region here. And while this is active, I'm going to also turn on include by edges. Okay, and I'm going to tick on unshared edges. Actually, it's not going to work. So let me pause for a second and I'll come back. Cool, so we're selecting this. I forgot the behavior that it's additive when you add more options to this node. So if I tick on unshared edges, it's going to select anything that has open edges. So let me copy this and we'll show you. If I don't have anything, nothing is selected, tick on include by edges. Nothing is selected yet. If I turn on unshared edges, it's going to select the boundaries. So what I need is I need this group node to respect this domain as well as this rule. But when we do it in the same node, it does not work. So what I'm going to do is I'm going to have it turn this off, and we're going to call this A. I'm going to copy this. I'm going to leave the name as it is. I'm going to turn this off. I'm going to include by edges, unshared edges. But see this initial merge here that says replace with existing? We have to keep the same name for the group for this to work. I'm going to change it to intersect with existing. You can see now we only have this guy. So this is the main thing. The unshared edges used to give us everything, but now it's taken into account what only the stuff that is in this group. So now we have the A section. Let's do the B section. So we want this part. Let's do this. It's maybe, yeah, something like that. And let's call this B. And let's call this B as well. And now we have the B group with just that. Great. Let's go back. Poly extrude. I don't need this anymore. This is now called group A. And you can see the result did not change. And you can click here to see the groups. B, it's called B. And now the mirror and everything works magically. So what else do we have that is not procedural? Let's go back. We have this edit. Again, I'm doing this live. I don't know if I will be able to get everything fixed or not, but let's see. So this joint is working. We have these 2 points that needs to be extended every time. So let's say after the fuse, we always need to change to move these 2 points. So what are these 2 points? Well, this is the first and last point, okay? And of this curve, as long as this is the same primitive, and we can actually find that. So this is 128, 21. This is 120. So the edge, this is not welded at some point. There is an opening in this curve that I can't find. So let's increase the fuse radius. Let's see if that fixes this. I think it's working. Let's try 0.1. And it's not sorting. So let's, I'm gonna fix, you can see the point number is not working correctly. So I'm gonna sort them again, and let's try this method. Let's try spatially located and see how that works. And I want these points to be, this to be 0, and this to be the last one. So this is not working. Let's try by y-axis. It's going to kind of work, but you can see here this is high, and then it starts going back to 77 to a lower point. This is 240. I think it's working. Yeah, so it's working using this this sorting, and we know that the highest point is the end, and the smallest point is the tip. Okay, so let's do this. We can access the number of points. This 241, we can access that. And we can access the point number 0. It's always number 0. So let's do this. Let's create a wrangle. Let's create a wrangle node. Let me think. Yes. So I'm going to use a syntax. If the point number is equal to 241, I'm going to create an attribute, call it end, and it's equal to an integer. It's equal to 1. Okay, let's take a look. So we have end is equal to 0 on all of them. Let's see, 240. Yes, so because we have 241, the point number starts at 0 and ends at 240. So if the point number is equal to 240, we are going to set this to 1. I'm going to copy this. If the point number is equal to 0, I'm going to set the end to 1 as well. And this way, I'm going to select both of them. So you can see this is the first point, and this is the last point. Now let's transform this. Instead of having this point explicit, I'm going to say if I'm going to say at end equal 1. And this is going to select the points where this condition is true. You can type in any condition in where you see a group, you can type in expressions like this. So I'm using this information to transform only the points. Let's see if this works. Let's move this. Kind of works. Yeah. Let's change something. Let's change the point number, which is very, very important. If we change the point number, it works, but we need to make this we need to make this dynamic. So how are we going to do that? Well, there is an expression called endpoints. And endpoints return the number of points available in all of this. And to access the point number of the first input, we're going to simply type in 0. And now that should give us the correct value. To verify this, I'm going to copy this guy here. And let's copy this. Copy this guy to show you this is working. So let's call this iTest, and let's take a look at this value. So you can see test is called is 241 now. Okay. So all we have to do is this is returning 241. We're going to subtract -1 because the endpoint is the total, because the point count starts at 0. Let's use this expression. And now everything should be dynamic. We're selecting those two guys. If we change this, yeah, it kind of works. Because all these are based off of the point number. So let's continue. Joint works. Great. Transform works. Revolve works. Edit, do we need this? We don't. Clip works, this guy works. And now we have let's say a fully procedural system of to create this guy. And we can go back and change any node, and it will propagate dynamically. So I'm going back and editing the curve, the soft transform of the curve. We can zoom in and change the radius, for example. You can see that's affecting the silhouette there. And because we have a copy, you can see it here as well. Cool. So this is just one way of creating this something that resembles to the art reference that I showed. Again, we didn't respect all this, but I want to show you guys how we can take a simple system using the soft transform and do all this. Now, obviously, if you're we don't have to make everything procedural. Again, when you build this, when you model this using classic tools, you don't think about making the entire system procedural. You do it once and then you update it as you go along. Same thing here. I just wanted to show you what needs to be done to make this procedural. So with a little bit of expression, selecting the last point and first point, and then doing this group trick to find the sides of each edge. That is still needed, needs to be fixed as well, because if we change the size of the circle, then we have to go back and fix these bounding boxes because they are based off a specific location. So there's all kinds of problems that we have to fix to just make a procedural system for this. But I think you guys got the idea. Let's move on to something else. Thank you guys for watching and see you in a bit.